Today, I want to talk to you about something that's both incredibly powerful and surprisingly simple: how to build AI applications with just 2 lines of code. Seriously, here's the 2 lines of code. I guess the talk's over. Okay. Just kidding. Just kidding. We will go a little bit further than that. But before we do start, I want to say that if you're expecting some complex lecture about machine learning algorithms or neural networks, you are at the wrong talk. Maybe that will be in the next one, but that's not what we're going to do today. Instead, I want to share something that I think is much more exciting and practical for all of us as developers. I want to show you how easy it is to build AI into your applications. So who am I? I'm Jesse Hall. You might know me from my YouTube channel, CodeStacker, or from my work as a staff developer advocate at MongoDB. So I want to ask you this question. Do you think you could be an AI engineer? Think about that. Do you think you could be an AI engineer? Well, when I ask people this question, usually the answer is no. And when I ask them why, usually they say things like, well, I've never studied machine learning, or I don't know Python, or I'm not great at math, I don't know linear algebra, or I don't even have a computer science degree. Well, here's the thing. Those are all misconceptions about what AI engineering actually is. And AI engineering is dramatically different from machine learning engineering or data science. So let me tell you something. The truth is that you can be an AI engineer, because I don't have a computer science degree. I don't know Python that well. And I don't know the first thing about machine learning models, but I am an AI engineer. Here's a quote from Swyx, Sean Wang, the author of Rise of the AI Engineer. And if you've never read this article, go Google it, The Rise of the AI Engineer. You really need to read it. But he says a wide range of AI tasks that used to take 5 years and a research team to accomplish now just require API docs and a spare afternoon. Isn't that really the case? And don't just take Sean's word for it. Here's another quote. In numbers, there's probably going to be significantly more AI engineers than there are ML engineers or LLM engineers. One can be quite successful in this role without ever training anything. Focus on that last part there. One can be quite successful in the role of an AI engineer without ever training anything. Now, that's from Andre Karpathy, the former director of AI at Tesla and from OpenAI. So let's look at this amazing diagram here, also from Swyx. And if you look at where the API layer sits in this spectrum, on one side we have machine learning research and machine learning engineering, the people building the actual models, training them. And then on the other side of the API layer, we have the AI engineer and the full stack engineer, people applying these models, implementing them to solve real problems. Now, I'm not sure where the majority of the audience here sits, but speaking from my personal perspective as a web developer, I sit on that right side of this diagram. And web developers consume APIs all of the time. And guess what? That's exactly what AI engineering is: consuming AI APIs to solve problems. Now, it is important to call out that this is not black and white. So there are aspects of the left side that can bleed into the right and vice versa. Now, of course, we have to understand how to use these APIs. There are many knobs that we can turn and tweak to customize things. But in the simplest of terms, it is just an API. And AI engineers, they really bridge the gap between ML engineering and product development. And they apply these pre-trained models and APIs to solve product challenges, focusing on integration rather than simply mathematical optimizations. So before we dive into the code, let's clarify what AI actually is. And there is different types of AI. So there's rule-based AI. So think of video games that you might have played as a kid. For me, it was Galaga, Pac-Man, Mario Brothers. They followed predetermined rules programmed into them by developers. And this has been around for a very long time. And then there's predictive AI, like when you're in Google Docs and it's trying to predict the next word, or on your phone's keyboard. These are statistic models that predict the next likely word. And then we have generative AI, and this is what's getting all of the hype now, models that can create novel content based on patterns that they have learned. And generative AI is exciting, but it has its limitations, doesn't it? AI can confidently make stuff up. It has no concept of truth. It hallucinates all of the time. It has even the biggest models have limited memory, so the context windows are very important. And then the knowledge cutoff. Most models stop learning at a certain date, and they don't know what happened after that. And so there is a technique that solves all three of these problems, and that is called RAG, which stands for Retrieval Augmented Generation. And it's just a fancy term for something actually pretty simple. And you might hear this explained to you in other talks. They might take the entire talk to explain what RAG is, but this is the most simple explanation that you will ever see. So screenshot this if you haven't seen this before. So RAG means to retrieve some up-to-date information from an authoritative data source, and then add that information to your prompt to augment your prompt. And then let the AI generate a response to a user's query based on that extra information. That's all it is. And that is, it's powerful because it gives the AI access to current, accurate information that it wouldn't otherwise have. And so to make AI work effectively, we need a way to find the relevant information and to include it into our prompts. And that's where vector embeddings come in. So what are vector embeddings? Well, they're basically a way to convert words, images, video, audio into numbers that an AI can understand. But not just any numbers. These are special lists or arrays of numbers called vectors or vector embeddings that can capture semantic meaning. So a quick brown fox gets transformed into an array of numbers. A common number of dimensions is 1,536 dimensions. Think about that. So in a 3D graph, you have an x-axis, a y-axis, and a z-axis. But this is much more than just 3 dimensions. This is 1,536 dimensions, which can contain significantly much more data. Now, just a side note, this could be a whole nother talk, but when it comes to dimensions for these vector embeddings, less is more. So just keep that in the back of your mind. Let's move on, and let's think of vectors as coordinates in space. So if I say the words like dog, cat, pet, these words should all land near each other in this mathematical space. Words like car, train, bus, airplane, those should land somewhere else, and so on. And so what's fascinating about this approach is that we're converting semantic meaning, actual understanding, into mathematical positions. And when an embedding model processes text, it's essentially plotting points in this high-dimensional space in a way where similar concepts could be clustered together. And this is where I stop. I have no idea how these calculations are made, and frankly, I don't care. I'm not a machine learning engineer. I'm an AI engineer. Remember, an AI is just another API. Understanding the core concepts, though, is what's important. So now it's demo time. Let's take a look at see some of this in action. So I'm going to walk you through a set of examples that demonstrates how easy it is to build AI into your applications. And we're going to use the Vercel AI SDK. This SDK makes it incredibly easy to get started. So let's start with the most basic example, text generation. So I'm going to type into this prompt, list all Star Wars movies by release date. Okay, so the LLM, the language model should know this information. Let's click generate, and then we will wait. It says generating here. And then we get our information here from the LLM. And this is as simple as it gets. We have a form here where we can type in a prompt and we submit it and we get the AI generated response. So if we go back up here, behind the scenes, here is the code that it is implementing. Starting with the back end here, we're using the generate text function from AI. This is from the Vercel AI SDK. We're also bringing in OpenAI from the AI SDK as well. And then if we scroll down, we have our generate text where we're passing in the model, the prompt, and then any other arguments that we want to add to it. And then we're just returning the response right here. And then on the front end, all we're doing is fetching from this generate API. So the magic here is that all of the complexity of calling the AI API, handling the response, and dealing with errors is abstracted away. So it's literally just an API call. So let's move on to this next example here, streaming. So let's do the same thing. List all of the Star Wars movies by release date. And notice what happens this time when I click generate text. It streams in. So instead of waiting for the entire response, streaming shows the text as it's being generated. So this creates much more engaging user experiences, of course. So let's take a look at the code here. Again, let's start with the back end. This time we are using the stream text function from AI. And then if we come down, we're just calling stream text, passing it the model and the prompt again, any other parameters that we want, and then returning this data stream. Now on the front end, we are using use completion from the AI SDK. So the AI SDK is broken down into back-end functions and front-end UI functions. This use completion hook handles all of our form actions, including input management, form submission, and completion results. So all we have to do is plug those directly into the form. So we have our handle submit, our input, handle input change, is loading. All of that is coming in here from this use completion hook. So again, very little code. The AI SDK handles all of this streaming complexity for you. Let's move on over here to text summarizer. So this example is a little bit more practical. You can paste in a long document, article, or any text, and AI will create a concise summary for you. So here we can insert some example text, and then let's create the summarized text, and that streams in much less text than we started with, of course. So let's look at the code for this. So on the front end, again, we're using that use completion hook. And on the back end, we are using stream text. That's exactly what we used for the text streaming example. The only difference here is if we scroll down, we're including a prompt here, summarize the following text in a concise, informative manner, and then giving it the actual prompt here. So this example shows how the same pattern can be applied to different use cases. The code is almost identical to our streaming example, but the application is completely different. Another example here is system prompt. This one's pretty funny. We're going to include this system prompt. You are a pirate. Always respond in a pirate dialect and use nautical analogies. That's my best pirate voice. What are the 3 largest countries in the land by land area is our user query. So we're going to generate the default behavior and then the behavior with our system prompt. So let's generate that. And here we go. This is just pretty bland and boring. And then here is in pirate voice. Let's take a look at something a little bit more advanced under structured output. So instead of just free-form text, we can ask the model to return data in a specific format like JSON. And so in this example, we show a couple of examples. So we have product extraction and sentiment analysis. So we have in here this product description, and we want to extract some key information from this. So let's go ahead and click extract product data. And we can see that it's breaking it down into some structured data. It's taking this product description and it's converting it into a structure that we can use to fill in specific fields here under this product data. So we're pulling the name out, the price out, category, rating, whether it's in stock, and the features directly from that. So let's take a look at the code for these. So on the front end, we are using use object. So unlike generate text, which returns a string, use object returns data that matches a specified schema. So we define our schema using Zod. So if we come down here to the API route, you'll see that we're using Zod here and defining this product schema, and we're describing it. And the backend uses this schema to instruct the model to output the data in this correct format. And then it validates the response against the schema to ensure that it is valid before it returns it. So again, this is so much code that you would have to write on your own, boilerplate code that the AI SDK is completely abstracting for you. One feature that I thought was extremely nice in the AI SDK is testing. So can you imagine having to test all of your API endpoints and all of the expense that could cost you in just the testing phase alone, right? So this example shows us how we can use mock models for testing different types of AI interactions. So we can use the use chat hook. This is an example of a mock configuration. And so we'll go ahead and send a message. Let's just say hi, send, and we get this mock response back. We can do the same thing with use completion, and same thing with use object. And then here is an example test using vtest. So here we're using the use chat hook here, and we're using this mock language model v1 from the AI SDK. So this lets us create deterministic mock models for testing. So you can configure these models to return specific responses, simulate errors, or even track token usage, all without making a real API call. And it's not all about text. Let's take a look at the alt image text generator. This demo lets you upload an image or use a random image, and then AI analyzes it and generates an appropriate alt text description for it. So let's go ahead and just get a random image. Nice, and then generate the alt text for this image. So we want to keep our character count under 125. We've instructed the model to do that. So we're making sure that this is a short, concise, descriptive description of the image. So let's take a look at the code. So on the front end here, we are just using fetch and just fetching from that API endpoint. And we are also passing it this prompt, generate a concise alt text for this image. And then in the API route, we are using generate text from AI. So we're passing in the image source and then the prompt, and pretty simple. And then in the messages, we are adding in the content. And so we have a content type of image here for this specific model that we're using. Not all models can be passed images, but in GPT-4o we can. So we're passing in that image and then the text with the prompt. And now not all AI has to be run in the cloud. The AI SDK also supports local models too. So we'll go over to the local model here, and we do need to make sure that we are running a local model. And we can use any model that is OpenAI compatible, like Ollama or LM Studio or any other self-hosted models that are OpenAI compatible. So we just pass in the base URL of our local model, the model name that we're running, and then ask it to do something. And there we go. We're running all of this locally. So let's take a look at the code. On the front end, again, using use completion. So on the back end, we're using create OpenAI compatible from the AI SDK and generate text and stream text, and then just using that local provider. Very simple. So it's extremely beneficial when developers want to work offline or they have privacy concerns or need to use specialized models that aren't available through cloud providers. Now here's where things get really, really cool is chat history. So let's go ahead and ask it a question. Let's say, what is my favorite color? And it's going to say, I don't know. I don't know what your favorite color is. So I'm going to say, my favorite color is black. Cool. Now I'll ask it, what is my favorite color? And it says my favorite color is black this time. So it remembered. So chat interfaces are more complex than simple text generation because they need to maintain a history of the conversation. And the AI SDK makes this very easy with dedicated hooks for React. So for example, this one here, let's go look at the code. We are using use chat. So use chat, we have our messages, our entire messages array, our input, handle change, all the other stuff that we're used to as well. So this is all built into the Vercel AI SDK. But what happens when you refresh the page? Well, of course, it forgets. So how do we create persistent memory? So let's go over to our chat persistence example. In this example, we can create multiple chats and keep track of the entire history. So let's create a new chat. And let's say, what is MongoDB? And it goes through and answers my question. That's a very, very long-winded answer there. But then we can keep track of multiple conversations, delete them, and refer back to them. And it keeps track of the entire history. So let's take a look at some of the code here. So we're using use chat, and then we are using some server actions. So create chat, save chat, load chat, list chat, and delete chat. All of these are interacting with MongoDB. So we can call all of these from the front end here with our use chat. So on finish, we can go ahead and handle that save and so on. So in our server actions, we define our database name and collection. And then we have a function here to create a new chat, to save a chat, load a chat, list chat, delete a chat, and so on. And then if we go down to the actual API route, we're just using stream text. And as we send and receive messages, we save them to MongoDB. But again, so far, we've only been dealing with the native LLM models just out of the box. So remember, we talked about RAG from earlier. Let's see that in action next. So this example implements retrieval augmented generation using MongoDB's vector search. And it retrieves relevant information from a database and includes it in the prompt to the AI model. So the first thing that this does is it makes sure that we have vector search indexes set up, and it makes sure that we have documents in our database that we can use to answer these questions. So if we go down here and we say, what is the Vercel AI SDK? It's going to answer this from the information that we have in our database. So if we go over here and look at the code, see on the front end, we are using use chat. We have some server actions set up to create our vector index and our example documents. You can see that here in this server action implementation where we are using Voyage AI as our embedding model. We're setting up our vector index and then seeding documents if needed, if they're not there. So we have some documents here relating to MongoDB Atlas, vector search, and the Vercel AI SDK. And then we insert those to seed the database and generate embeddings along the way. And here is one of the most important function is find relevant documents. So this is the function that we call when we are looking for the correct documents using vector search. So we take the user's query and we create an embedding for their query so that we can compare this embedding with the embeddings that we already have in our database. So we tell it which collection to look at, and then we look for the relevant documents using vector search. So on the API route, very, very simple with a stream text where we're just sending and receiving messages to the AI. The only difference here is that we are getting the relevant docs from our find relevant documents server action, and then we're injecting that into our enhanced system prompt, adding more context before sending it to the LLM. So each of these examples kind of build upon the other. We've gone from very, very basic things and now into RAG implementations. So next we'll look at something much more advanced, and that gets us into Agentic AI. Let's look at tools. So here we're going to ask it, what is the weather in New York? And also, can you calculate 2003 divided by 7? So we're asking it two completely different things. So if we run that, we'll see that users asking this question, and here's the assistant answering the question. But what did it do in order to get this information? Well, it actually ran two tools. So we have a tool called Get Weather, which gets the weather from the location that was asked for, and then Get Weather returns that result. And then we have another tool call, and there's a tool called Calculator, which is going to calculate this, and here's the result that it returned. So on the front end here, again, we're using use chat, and then in the API route, we're using generate text and tool. So in here, we can specify the different tools that we're going to define here. So we have our Get Weather tool, and we're describing it, Get Weather in a location, using Zod to validate this and to describe it. And then in the execute, we have our function that will execute here, returning the specified parameters. We have another tool called Calculator, which calculates a math expression. And then here in our generate text, we are then going to pass in those tools, give it a max step so it doesn't just continuously go, and then on finish, return each one. So this pattern lets you extend AI capabilities with custom functionality, whether it's searching a database, calling external APIs, or performing calculations. The sky is really the limit here. And for our final example, let's look at a complete agentic application. We have a social media agent here. So we can pick which platform and then give it an article or something for it to create some social copy for. So let's go ahead and generate a social media post based on this article that's already in here. And so what it's doing here is it's going through each of these steps, drafting up the content, measuring the engagement, adding some hashtags, and then here is the final post. So here are the steps that it took. So it went through, and the first thing is it analyzed the article that we gave it. Maybe I should work on the CSS here, but we can still read this. So the second thing that it did was generated the actual post. It evaluated the post, giving it a score of 1 through 10, added some hashtags, and then sent over the final post. So let's take a look at the code here. All right, so on the front end, again, we're using use chat here. And then on the back end, again, we're defining our tools. We have our analyze article tool, which extracts key information. Then we have our generate a draft social media post, so generate the post tool, and so on. Then we create our data stream response and pass in those tools and allow it to go through each tool and then return the responses. So this example brings together several concepts that we've explored: structured output for generating formatted post content, tools for generating hashtags and checking character counts, RAG to pull in relevant information about the topic, and a chat interface for iterative refinement. So what have we learned today? Well, building AI applications doesn't require a PhD or even deep AI knowledge. It's about using the right tools. The Vercel AI SDK reduces complex AI implementation down to just a few lines of code. And by combining these simple primitives like text generation, tools, and RAG, you can build powerful AI agentic applications. Now, the key takeaway here is that AI development is becoming increasingly accessible. You don't need to be a machine learning expert to build powerful AI features. You just need to know how to use the right APIs and tools. So give the Vercel AI SDK alongside MongoDB a try in your next project. Thank you.